Okay, today we're going to go over implicit derivative notes. And this word implicit is going to be new to most of us. But, basically functions have two forms. And so far, everything we've seen, for the most part, usually is in explicit form. And what that means is we've already solved for y, right? Like y, or we could call it f of x, but it's already, the function is solved for y. So we have y equals something. In implicit form, okay, it's no longer, the function is no longer explicitly something, it's implied, that, okay, whatever x is, y, has to equal 1 then. So basically it's not solved for y. So this would be an implicit function. Now, if we wanted to take the derivative of this, right now we don't really have a way to do that, but what we could do is we could just solve it for y. So we could say that the implicit form, we have x times y equals 1. If we divide both sides by y, or by x, then that gets us to the explicit form, and we have y equals 1 over x, or x to the negative first power. And now, here we can do the power rule. We can take the derivative. So, dy dx equals negative x to the negative second power, or negative 1 over x squared. So, everything we're not always going to be able to solve for y. Before we go into that, I'm going to go over just when we take the derivative with respect to x. So remember we said that d dx, this is like saying we're taking the derivative with respect to x. So if I want to take the derivative of 3x squared, that's d dx of 3x squared. And we notice that the variable that I'm taking the derivative with and the variable that we're taking it with respect to, they agree. Okay, so it's derivative with respect to x, and our function is 3x squared. So that's, when I say agree, it's basically saying it's the same variable. So this, when we have variables agree, you just do a normal derivative. Product rule, power rule, quotient rule, chain rule, whatever we want to do. So in this case, it would be product rule, and we get 6x. Okay, now technically, if you wanted to do a chain rule, right, it would be, okay, we did the outside, which was 3x squared. The inside of this would actually just be the x, so it would be times the derivative of x with respect to x, which is just 1. We never do this, I haven't shown you guys that, because it's always going to be 1. So when we do the derivative of something different, though, like the derivative with respect to x of y cubed, now we see that our variables don't agree. They're different. So we're taking the derivative with respect to x of a y. So those variables are different, and this here, when they're different, that means that we have to do chain rule. So what we do is we say, okay, our inside is the y, so it's 3, the derivative is 3y squared, and we have to do times the derivative of y, and it's the derivative of y with respect to x, so times dy dx. So that would be the derivative of 3y squared, or of y cubed would be 3y squared dy dx, because we're taking it with respect to x. Just a quick side, if we did decide to do the derivative with respect to y, which you can do, of y cubed, it would just be 3y squared, because our variables are the same. But the derivative with respect to x of y cubed, this is where the variables are different, so it's 3y squared, and then you have to do the chain rule times dy dx. So that's kind of our difference, is variables agree, just normal derivative. Variables disagree, then you have to do the chain rule, which is just multiplying by that there. Also, sometimes people will write this as 3y squared times y prime. That's the same thing. I prefer dy dx just to make sure that you don't actually think that that's the number 1. It's y prime. So I just want to go through a couple more examples. If we did the derivative with respect to x of x plus 3y. Okay, those two variables agree. So, the derivative of x is just 1, plus these disagree, so the derivative of 3y is 3, but now we have to do a chain rule on this y term, so 3 times dy dx. And then lastly is the derivative with respect to x of xy squared. Now in this case, you'll notice that we're multiplying those. So we're going to have to do a product rule. So, product rule, right? We take the derivative of the first term. So I'm taking the derivative of x, leaving y alone. So while I'm doing that part, the variables of what I'm doing the derivative of agree, right? So that's the derivative of x is just 1. I don't have to do chain rule, they agree. Y squared. Plus, now I leave the first term alone. So I leave x alone. And I take the derivative of the y squared term. This is where they don't agree, they're different. So the derivative is 2y, but we have to do chain rule because they don't agree. Dy dx. So that would be our derivative here. And then, if you want to factor anything, you can do that. Okay, so I want to do a couple examples with this. The first one's going to say find dy dx, right, the derivative, given that y cubed plus y squared minus 5y minus x squared equals negative 4. Now when we're doing the derivative, right, I'm going to rewrite this y cubed plus y squared minus 5y minus x squared equals negative 4. When we're doing the derivative, it's kind of like any operation in math. You add to both sides, right? You could add x squared to both sides, or you could multiply a number to both sides, or divide a number to both sides. It's kind of the same thing. So what you're going to do is you're going to take the derivative with respect to x of both sides. And this just goes to each term, right? We multiply it out, we expand it out to every single term. So it's going to be the derivative with respect to x of y cubed plus the derivative with respect to x of y squared minus the derivative with respect to x of 5y minus the derivative with respect to x of x squared equals the derivative with respect to x of 4, or negative 4, I guess. Now, in this case, right, you don't really have to write this out every single time. You can just start doing it. So when you get good at this, you can just kind of skip writing everything I just wrote out in red. You just basically go straight to, okay, I know that the derivative of y cubed is 3y squared dy dx, because it's going to be that implicit chain rule. My variables are different. Plus 2y dy dx equals negative, minus 5 dy dx minus 2x equals, now the derivative with respect to x of negative 4, it's a constant, so it's just going to equal 0. So just really quickly to review, derivative of y cubed is 3y squared, but we have to do the chain rule dy dx. Derivative of y squared is 2y, we have to chain rule it. Derivative of 5y is 5, but it was minus 5, and then we have to chain rule it. Derivative of x squared is 2x, right, minus 2x. The variables were the same, so we don't do the chain rule. And if you did, it would be dx dx, which divide anything by itself is just 1. And then derivative of any constant number is 0. So now I'm to this step in blue. And remember, we're solving for dy dx. So I have a dy dx here, here, and here. What we're going to do is we're just going to move everything that's not a dy dx over to the other side, and then we'll be able to factor it out. So right now, the only term that doesn't have dy dx is this negative 2x, so we're going to add it to the other side, and we'll end up with 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. Now we see that we have dy dx everywhere, which means we can factor out that term dy dx. So we factor out a dy dx, we're left with 3y squared plus 2y minus 5 equals 2x. And then we'll divide both sides by 3y squared plus 2y minus 5. And that cancels, and we end up with dy dx equals 2x divided by 3y squared plus 2y minus 5. We're going to check, see if we can factor this at all, or if we can simplify anything. We can't, so that's going to be our answer right there. Sometimes a problem will ask you to do a little bit more. It'll ask you to plug in an x or plug in a y and get a value, but this is kind of the basic implicit. Okay, so that's going to kind of bring us to our next example, which is going to be finding the slope of an implicit function at a certain point. Now, when we see this word slope, we're immediately going to think of derivative, which is, dy dx. And at this point, 3, 1, that means x equals 3 and y equals 1. So first we're going to take the derivative, then we're going to plug in x is 3, y is 1. So I'm going to take the derivative of both sides with respect to x, and that gives me the derivative of x squared is 2x plus the derivative of 4y squared is going to be 8y, but these are different, so times dy dx equals, and the derivative of any constant number is just 0. Now we're going to solve for dy dx, so I'm going to subtract 2x to both sides, and that gives me 8y dy dx equals negative 2x. We'll divide both sides by 8y, because remember we're solving not for y but for dy dx. And that gives me dy dx equals, we can simplify that to negative x divided by 4y. Now, in the last problem, this would have been our answer right here. But this is the derivative. We want to have the slope of this line at the point 3, 1. So we're going to just plug in that x equals 3, so it's going to be dy dx equals negative 3 divided by 4 times 1, which is going to be equal to negative 3/4. Okay, last problem I want to do is just a problem with kind of chain rule in here. So I want us to just find what would be the derivative if we had something like 3x squared plus y squared squared. And so if we take the derivative with respect to x, we see this is our inside. This is a chain rule. So we bring the 2 down. That's 6. We leave everything inside alone. X squared plus y squared to the first power. Now we multiply by the derivative of the inside. I'm going to put a parenthesis here. The derivative of x squared is 2x, right? These are the same. Plus the derivative of y squared is 2y times dy dx. So that's just an example of if you had to do the derivative of something that would involve chain rule. You don't multiply by dy dx here. You only multiply once you actually take the derivative of something that directly has the y in it. Alright, that's it for the notes. I'll see you guys in class.